Good morning, one and all. This is Alampala Akhil from Institution of Aeronautical Engineering. As my room was fast on the screen, I am related to the aeronautical engineering, and today my tech talk topic is in aerodynamics, application of morphing techniques, and the Cartesian grade to aerofoil design. Here about the introduction, a cross section of a body such of a body such as a wing that provides a lift as it passes through the air fluid is called an airfoil. Despite the fact that airfoil has a very simple geometry that can be represented by the polygon lines, the shape is a critical factor in the turbine performance, making it necessary to optimize the airfoil for the maximum lift and the minimum drag. The article compares the usage of the morphing methodology from the rapid aerofoil creation with the Cartesian guide method from the quick mesh developing and from the morphing techniques models from the CFD performances. If CFD is known as computational fluid dynamics and as principles of an aerofoil. First of all, of the principles of aerofoil where kinetic energy is converted into the mechanical energy. Given that is an object that has a motion of kinetic energy, and the kinetic energy can be equals to half mv square, where m is known as the mass and the v is known as velocity in meters per second. Wind and the ocean currents are kinetic energies, and since they are the motion of an air and water respectively. Wind turbines and the ocean current turbines both transfer the kinetic energy from the wind and the ocean currents into the mechanical energy. It means that the kinetic energy from wind and the ocean into the mechanical energy. And the morphing. Morphing is an interpolation technique that simulates that the transition of one thing into the another. In some fields, such as computer-generated animations, the morphing techniques is commonly used. However, the techniques has only been using a few times in the product designing the process so far. Since then, the technology has moved to the film business and it now widely utilized in the animated tanks to advertisement of a powerful computers. You can observe able to know that figure 1 where the figure one person shows that old and one person shows as middle age and one person shows as somewhat young age. This is known as a 2D experimental image of morphing. And shows in a 2D image of morphing, the techniques can also apply to the 3D object and the most of the moderated animation is in the world. And types of morphing. And types of morphings are called morphing, multi-pair morphing, and mapping and extrapolation. These are the types of morphings. There are 4 types of morphings. And first, we are able to know that Cartesian grid. Cartesian grid. Cartesian grid consists of a rectangular or a cubic in 3D cells which is aligned to the axis of the coordinate systems. And the grid method has been forecasted for the fluid dynamics calculations. And there is also with the geometry. With the high orthogonality, low spinniness, and the good aspect ratio, even for the complex geometry solutions, the Cartesian grid tends to coverage the better than those modified methods. An example of Cartesian grid is whereas able to observe that figure as shown in the figure. And morphing airfoil profile is very important for the good performance of turbine. Since the total depends on the lift and the drag of the airfoil. In order to examine the feasibility of using morphing generations of airfoil, we can able to observe that there are 6 airfoil stretches as shown in the figure. Where first one is known as which first figure you can able to observe that the t equals to 0.0 and the second Here B can able to observe that t equals to 0.1, where there is a tailing edge slightly different, where C equals to t equals to 0.2, where D equals to t equal to 0.3, where E equals to t equal to 0.4, where F equals to t equal to 0.5, and parent model is a newly generated models. In PCT or EF and the newly generated, where A is a parental model which can be described from those PCDEF. This is the morphing of aerofoils. In the Cartesian grid generation, the Cartesian grid generation with the intermediate models construction through the morphing approach, a Cartesian grid can be generated. This paper used for the Cartesian grid method to crystallize a common CFD, where CFD is known as computational fluid dynamics programming and fluid that use it to the finite value approach. In software, in Fluctuate software, an example of a Cartesian grid is shown in the figure, which is built for the model of creating using the morphing approaches. Modeling the morphing parameters and can be used to build the Cartesian grid. And we can able to observe that the figure there is a green color and there is a ash. We are able to see there are airfoil design morphing, where Cartesian grid is a modeling at 0.7 morphed at the between fx at 77,080, where and the E is 47,473 aerofoil. This is the designing of an aerofoil of a Cartesian grid generation. And a small conclusion that this research looked at how to use the morphing approach to generate a large number of intermediate forms quick, as well as Cartesian grid method for the high quality grid production of the complex relations geometrics created using the morphing techniques. This is specified with the morphing models and the meshes. Meshes may be generated for the CFD. The CFD is known as computational fluid dynamics is a particularly applicable on the and useful of airfoil design. It was it was discovered that the combination method has a lot of a potential and a powerful tool for the airfoil design of an optimization. This is about the morphing technique of an airfoil.